learning, and clustering and association rules are unsupervised learning, right? Now, so regression. So what is the so we have a supervised learning in regression and classification problems. Then what is classification regression? So normally regression is to make relationship between the variables, which means that so our features are attributes. So input is comes from various sources. We need to pre-process it. After that, we need to extract the suitable features. From that features, we need to make the relationship between the features to make complete prediction. So regression is a statistical model which applies over various domains or areas like finance or investing or any other disciplines. So ultimately, we need to check which one is a hyperparameter for giving better performance. It is also used in predictive modeling. We need to predict the future with the help of the regression analysis, right? So that there are two types of features. One is dependent and independent. We'll discuss later. Now, regression analysis, right? So this is predictive modeling technique. We need to predict the future. So how to predict the future? We need to analyze the attributes, so which is collected from various sources, right? So there are dependent variables and independent variables. So we need to take some features. Based on the features, we need to identify the past prediction or predictive result. That's the future. So feature is the attributes, future is a predictor result. So normally the regression is classified into two types based on the data we are using to predict or we are going to predict. That's a linear and non-linear data. So based on that, we can classify the regression into multiple types. We'll discuss later, right? Later slides. So ultimately, the regression technique is used to determine the strength of the feature for the next subsequent future, right? So regression always use the mathematical or statistical concepts. We need to use some straight line mechanism to check whether the data is correctly predicted or not, right? So this is a regression analysis related to linear and non-linear data. Now this is an example where we apply the regressions. Suppose consider the data set. So the data set contains the housing data, housing details, right? So we need to predict the price of a house, right? Normally the regression has two variables, independent and dependent variables. What is independent variables? There is input feature. The dependent we are going to predict, right? So see here in the data set we have a number of features. There's the size, locality, number of bedrooms in the house. The data set contains these features. So what is our ultimate aim? We need to predict the price of the house. So how to predict the price of the house? We need to analyze each and every feature and select the hyperparameters, that's the hyper feature, and make the relationship over the features and predict the house, pricing house. So what is independent variable? So the variable is nowhere related to any other. So dependent variable always depends on independent, which means that if there is any changes in independent variable, right? So ultimately the dependent variable gets changed. So this value is depends on the independent variables. Right? So ultimately the regression is used to make the relationship between dependent and independent variables. So what are the independent variables? Size, locality, and number of bedrooms. So our price is fully based on these variables, and the dependent variable is predict that price of a house. Now, so what are the dependent and independent variables? So as we discussed, this data set contains some features and predict a result. That's the price. So data about the house is a independent variable, that is a predictor variable. This variable is going to predict the future, so which contains the number of bedrooms and size of house, like that. So it is also known as the predictor variables, right? Next we have a dependent variables. The dependent variable is fully depends on independent variables. Our response is we are going to predict the price of the house. This is also known as response variable, right? So if there is any changes in independent variable, it automatically depends on our dependent variable, right? So that is actually a two different variables. So based on that, we can perform regression analysis, right? We need to fix the independent variable and dependent variables, right? Now, so the data is divided into two categories. Before applying any machine learning techniques, we need to fix what are the types of data we are going to use to perform further analysis or learning or prediction or whatever it is, right? So there are two categories, univariate and multivariate, because so far we discussed about the variables, right? Independent variable and dependent variables. And what is variable? What it contains? So variables needs for the prediction or machine learning purpose. So variables is categorized into univariate and multivariate, right? So univariate, which is used to perform or holds only one type of value. For example, the temperature, right? So temperature is only one value. We need to perform the analysis over the single value. So that is univariate. So that variable is classified into either categorical or numerical, because these are all the data and variable types we need. Then only we can perform further processing. We can understand further model and its performance, right? So categorical and numerical. So this is a univariate type. So what is categorical means? The categorical value which contains one or more categories. It's the values which has one or more values. That is also known as discrete values, right? So numerical values are also known as continuous variable values, which has some intervals, finite or infinite intervals. We'll discuss, right? So this is the best example for univariate. So we have a temperature. We can easy to analyze what is the minimum temperature, what is the maximum temperature, what is the average temperature. So based on that, we can apply some statistical method to check and analyze to predict what could be the next temperature, right? Now, so we can plot it in any visualization techniques. So this is univariate, only one variable is enough to analyze. Now, so we'll discuss in detail about these variables, continuous variables. So assume that there are number of persons, right? Now every person has its own weight, so that is actually continuous. It has an infinite number of possibilities, 160, 160.11 or any kind of weights, right? So that is goes on infinite number. So this is a continuous variable. The person 1 has 160 pounds and person 2 has 160.11, like that. So that is goes on continuous number of values. So that is a continuous variables, right? So weights are limitless, right? Now discrete variables. So it is a numerical values. It is a countable values, which means that we need to count the number of customer feedback or how many customers are giving the feedback, or number of defects in the software or any kind of products, or how many students or how many employees are getting more salary. So these are all the things are comes under discrete value. These are countable numbers, right? Now categorical value. So there are various groups. Assume that the gender we have a male and female, right? So categorical values are considered as a number of elements with specific categories. So we have a multiple groups or multiple categories. So based on that, we can perform further prediction. So these are categorical. So continuous and discrete and categorical variable. For example, in the categorical variables, the gender we have male and female, and single or married. On payment method, we have plenty of payment methods. So these are all the categorical values, variables, right? So this is comes under univariate. Now bivariate. Now the bivariate or multivariate, more than one variables are going to use to predict something, right? So that is multivariate. It is also known as bivariate. So bivariate is also a multivariate. So bivariate uses two variables or two or more variables to make some prediction or predictive analysis. That is called predictive modeling, right? So bivariate analysis uses relationship between two variables. So the independent and dependent variables. So we always keep our independent variable as a x-axis, dependent variable is in y-axis. What's the meaning of that? If there is any changes in x-axis, that is independent variable, there is some changes in dependent variables, right? So bivariate can have any combination, numerical to numerical, numerical to categorical, categorical to numerical, or continuous to numerical, anything, right? So based on that, we can classify that problem into regression and classification, right? So here, so this is the clear representation of classification versus regression. Now we can understand. So based on the data of independent and dependent variables, we need to categorize the problem into regression or classification. Both are predictive modeling, right? So if it is a regression problems, because both are supervised learnings, right? So in regression, the x variable, what is x variable? It is a independent variable. It can be numerical or categorical. Now, what is the dependent variables? It is always numerical. So this kind of thing is considered as a regression problem, whereas classification problem, so the x variable, so that is a independent variable, that is a numerical or categorical, but the output always a categorical. Now you can see we have numerical, categorical, or continuous, or multiple types of variables, right? So based on the variables, we can categorize into regression and classification. Is it clear? Okay. Now, so how to make the relationship? How strong the variables is? How to do it? How to analyze it? So there is a coefficient called Pearson coefficient. So we need to find the correlation between the variables, right? So What is correlation? So the strong linking of the variables, how the x and y variable is work together. So that is correlations, right? So there is no correlation, all the data is scattered. So the correlation always has positive and negative based on the type of independent and dependent variables. Suppose if it is a positive correlation, if there is any changes in independent variable, it is the increase in dependent variable. So that is a positive correlation, which means that everything is in higher number. Correlation is so high. If the correlation is low or minimum, definitely it is a negative correlation, right? So based on the correlation, because our regression problem is fully based on how the variables are related each other to make the prediction, right? So this is, we have plenty of coefficients. One of the coefficient is Pearson coefficient. So this is actually a coefficient formula, right? Now, so we have some use cases. Assume that. So there are two types of relationship: positive and negative. So what is positive relationship? Assume that the independent variable is study time, dependent variable is grade, that is a GPA. So if the study time is large, definitely there is a possibility to get higher GPA. Definitely the GPA gets increased. So that is a positive relationship. So there is an increase in study time. Ultimately, it increases the grade. Now, what is the negative relationship? So if you are spending more time on Facebook, definitely we get minimum grade. So that is a negative relationship, right? So in the regression, fully based on the regression line analysis, right? So the positive relationship, if there is any changes or increase in independent variable, we get the increase in dependent variable. Whereas the negative relationship, if there is the increase in independent variable, there is a decrease in dependent variable. So there is a positive and a negative. Now, how to perform the regression analysis based on the positive and negative? So ultimately, we use the straight line. So this is the logic behind the regression. We are familiar with that. How to draw a straight line? We have formula y is equal to mx plus c, right? So this is gives the positive line, positive relationship. So for that we can draw the line like this. If it is a negative relationship, we can use mx minus c, right? So here y is a dependent variable, that is a predictive variable. X is a dependent variable. B naught is a interceptor where our line starts, right? So if it is a positive, it is a positive relationship. If it is a negative, it is a negative relationship. So these are all the basics, right? Now, see here. So the regression line uses the correlation effect or relationship between the independent and dependent variables, as we discussed. So we need to find the best fit line. How to find the best fit line? So that line holds all the data points. So that line is best line, right? So initially we need to scatter our data because data is in different orders. We cannot get the same data to predict. We need to collect the multiple data. So those data are make the complete prediction with minimum error. So we need to form a best fit line, right? So once you form a best fit line to check or analyze all the data points, so there's error also, right? So the point is close to line, that is perfect prediction. The point is away from that line, there is a difference, that difference is error, right? We have plenty of mechanisms to calculate the errors. We will discuss later. So here, so we need to, so another thing is coefficient of determinant. So it determines the fitness of the linear model. So we need to analyze the fitness based on the line and based on this coefficient. So all the point is closest to line, it is best fit. It is away from the line, that is considered as a outliers, right? So here, so how to check or fix the best fit line? So that line always taken from x and y. So this is the mean value of x and mean value of y. That is called x bar and y bar. The intersection of x and y, that point allows the line to pass to either negative or positive, right? So after that we can find the data points is closer to the line, right? So that is actually a coefficient of determinant. So far we discussed about some basics about regression analysis and variables. So normally the supervised learning is classified into regression and classification, and we have variables. Ultimately, regression analysis is make a relationship between independent and dependent variables, right? And what is variable? So we have different types of variable. Then continuous, discrete, and categorical. So based on that, we can classify regression and classification problems. So far we discussed things, right? Regression always use straight line model to predict the futures, right? So there are various kinds of regression analysis: linear, logistics, and polynomial. We have plenty of things, right? So these are all things most commonly used. So as we discussed earlier, the data is classified into either linear and non-linear, right? So linear data, logistics also linear data, polynomial is non-linear. If you want to handle non-linear data, you choose polynomial regression. We have some pros and cons, we'll discuss later. And linear regression, logistics, especially for linear data. So let us start with the linear regression, right? So this is a conceptual relationship between independent variable and dependent variables, right? So there is a straight line. The yellow dots are points, right? And so the point is so close or so far away from the lines, right? The straight line, right? So this is actually a regression conceptual diagram, right? Now we need to use the linear model with the help of the formula y is equal to mx plus c plus e. What is y? It is a dependent variable. We are going to predict mx is a slope, m is a slope, right? C is a interceptor, e is an error, right? So we need to make the dependent and independent variable and its relations in linear manner through linear regression. Now, so the linear regression is a supervised learning model. You are going to predict based on the dependent variables and independent variables. So dependent variable always continuous, right? So independent variables, it can be either continuous or discrete, right? But we need dependent variables always continuous. So example. So let us take one example related to this linear regression. So there is a relationship between the time and stock price, right? So if there is any changes, so the stock price is depends on time, right? So we need to predict the various time with the stock price, right? So the yellow dots are actual price, and this is a predictive price. So some points are lie on the straight line, so that is a predicted price. Away from that line is actual price. So the difference between that actual price and predicted price is a error, right? So this is just we have discussed, right? So what is y? It is a dependent variable. P is a b naught is a y-intercept, and b1 is the slope. Okay. Just a minute. My connection get lost. I have to reconnect it. So this is actually a formula, right? For making the better linear regressions. So slope independent variable and error, right? So error is the deviation between the actual variable and the predicted variable. So here another example. So we have a different data points. There's the data or features. So the scatter plot is the best choice for making better understanding of regression analysis, right? So see here, assume that we have a totally 7 dots, purple color dots. So that is a 7 data, right? So purple dots are the points or features of the input data, and the blue line is a regression line, that is a predictor line. Red line is an error. So as of now, we have discussed so many things. Do you have any doubt in this? Any clarifications? Is it okay?
Hello, sir.
Yeah.
Sir, in the equation, you mentioned like y is equal to b naught plus
Yeah.
b1 into x plus error.
Yeah.
Error we will get after predicting the line only, na?
Yeah. Yeah. Yeah.
Means how we write the equation means like my question is,
Okay.
we add the error into equation after predicting only.
Yeah. This is a generalized equation. So we have a equation y is equal to mx plus c, right? So we fit the line on the plot. Now,
Yeah.
so after that, we need to perform or calculating the errors. What are the deviation between predicted and the actual? So that also included in our outcome, right?
Yes, sir. But my doubt is after predicting only, after prediction the
Yeah,
line,
yeah, yeah,
after
yeah,
that only we
yeah,
have to add the error. Means
yeah,
before we
yeah,
can't
yeah,
add.
yeah, 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 yeah.
Thank you, sir.
So yeah, right. So we use y is equal to mx plus c for identifying the points. After that, we check the accuracy. How to check the accuracy? definitely we have some deviation. So there is a predictor and actual. So we take that difference. That difference is considered as a error. So that also a component of our modeling, right?
Sir,
So this is,
by means always error existing means we can't minimize error, na?
yeah. So
Because
for that, yeah.
during prediction, I'm not considering the error. So always error must be exist in this model.
Yeah. So it is depends on the features. So
Thank
that
you.
is our job to predict what could be the correct prediction. How many, suppose if it is a customer, how many customer are eligible to get the loan, right?
Yes, sir.
So we cannot minimize the customers, right?
Yes, sir. Yes.
Yeah, based on the input. So they receive some data from the customers. Based on that, so these are all the customers are eligible to get the loan. So we have to predict like this, right? So we cannot change the customer data for our better prediction, right?
Okay, sir. Thank you, sir.
Yeah. So this is error term. So after plotting or finding all the data points, we need to find out the difference, the actual and expected price. So this is the actual price or actual data, right? So the closest to line, it is a predicted data. Some of the points are on the line, lies on the line, that is perfect prediction. So if there is any deviation, so there is an error. So that is a error term. So error term is the difference between expected price. So for example, we need to make some price prediction, right? Or expected value or observed value, right? So this is a expected, this is actually actual and expected. This is the formula. We'll see how to do it. See here. So this is the actual, this is a predicted. This is actual plotting, this is a predictor, right? So there is a difference between the actual and predicted. We can get the error. So we use various techniques to identify the errors or get the errors. One of the technique is mean squared error. So it is the mean value of all the errors, right? So the sum of all the errors, because we have different features, right? We get the outcomes, and the mean value is 1.02. This is the error value of this particular prediction, right? So now we'll see some how to perform this linear regression, right? Mathematically. See here. So I am going to use two variables, right? Assume that it is 1, 2, 3, 4, 5. Now I want to use 2, 4, 5, 2, 5. This is the y variable, right? So x and y. We need to plot it, right? So this is a independent, this is a dependent. So there is a formula, right? So we need to find out the y is equal to mx plus c. Here we can change little bit different in terms of naming scheme, right? So y is a predictor value is equal to b naught plus b1x, right? So what is b naught? So we don't know anything. We have to find out x and y. What is x and y? Because we don't know where we need to place our line, in which order, where it is coincide. We don't know, right? So how to do it means, so we need to take the mean value of x first, right? For example, here, how to find out the mean value? Sum of these values, right? Divided by 5 values, right? So automatically the mean value is 3, right? Likewise, we need to take the mean value of y because we need to find out the interception, right? This point. How to find out the point? We need to take the mean value of independent and dependent variables, right? On x and y. How to do it? Sum of these values, right? Now divided by 5 because I have 5 values. Now, so where we can get the interception? Ultimately, the scatter plot is best choice for our visualization or understanding. We need to plot in scatter, right? So this is actually a scatter plot for our input data. Now we need to fit our line, right? How to fit the line? So 3 is a x, right? So we can take the x bar. So this is a x. So 3 and 3.6, for example. Assume that. So 3.6, let us take here, right? So we can change the color. Here also we can change the color. Yeah. Right. So this is a 3 is the mean value of x. These are red lines, black line shows it is a one line. So this is the interception, right? This is a point in which the line get crossed, right? So this is actually a first analysis, right? See here. So we have found the x and y, this interception. Now we need to find the y intercept. What is b naught, right? So b naught is an important variable because we cannot simply start anywhere, right? We set the point, right? So we need to select the best line, best fit line. We cannot simply draw like this. It is wrong. So there is a point we need to analyze, right, for best fit. After that, we can get the points or which are closest to our line. That is best predicted. The main thing is outliers. Is it okay? Is it clear? Shall we continue?
Yes, sir.
Yeah. Thank you. So now I can see. I can see here. So this is actually a data points 1, 2, 3, 4, 5, and y 2, 4, 5, 4, 5. Right? Now, so we need to find out the mean value, right? So how to find out the mean value? We said so 3 is the mean of x, 4 is the mean of y. Now this is the formula we need to find out the slope. That's a b1 because here we have y is equal to b naught plus b1x. Now we have found x is a 3, y is a 4. Right? Now we need to find out b1 and b naught. So how to find out the b1 and b naught? Now x minus x mean, right? And y minus y mean, because this is a formula to find out the m, right? So we need to find out these things, right? Now what is x value? So this is our x value minus mean. Mean is a 3, right? So ultimately minus 2. Now we need to collect all the mean values, right? Now likewise, we need to get mean values with the difference of y 2 minus 3.6. Now, so this is actually a x minus x bar. So I specified here x1.
Sorry, in that, sir, maybe I found some mistake. In the second one, 2 minus 3 minus 1. After 2 minus 2 minus 1, like that we will get, no?
Here.
Yes, after the next one.
This one.
Yes, sir. That is 2 minus 3. It's minus 1, I think.
Uh, let us check. Let me check.
Okay.
Uh, is it right? So it is. Now we can check. Yeah, you are right. I found some. It's actually 2, right? This 2, right? Now you can see here value here -1, right? -1. It is 0, right? 0.
Not the, so those are y values. Actually, those are right only. The x
Yeah, yeah,
minus
yeah,
x.
yeah, 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 yeah. Yeah. Here. Yeah.
Yeah.
What is the value I mentioned earlier? 5, right? Or 4 or 3, right? Okay. Any values. Now here, right? 3
Yes,
minus
sir.
1 minus 1, right? Yeah. -1. So this is actually 0. So some problem in my calculation. Okay, thank you. This is actually a 1, right? So this is actually a 2. Okay. So likewise here also, it is -1.4 like this. Okay. So this is actually a value, right? X minus x bar, y minus y bar. For your understanding purpose, I can use this. So this is better understanding to you. Now, is it clear?
Yes, sir.
Yeah. So this is x value, this is y value. Now x minus x mean. So 3 minus 1, 3 minus 2, 3 minus 3, 3 minus 4, 3 minus 5. Now 4 minus 2, 4 minus 4, 4 minus like that. So we can get like this. Now we need to make this square. Now we can get like this, right? So 2, where it is? So 2 into 2 power 2 squared 4, 1 squared minus 1 squared 1, 0, 1, 4. Now we need to multiply these two terms, right? So ultimately we get these output. Now we need to find out the summation of everything because we need summation, right? So 10 and this 6. Now 6 divided by 10. Ultimately it is 0.6, right? So now we have found B1. So we already found X and Y. Now we are having B1. Now from that we easy to find out the B0, right? So B0 is a 2.2. Now this is the interceptor. We need to start our line from 2.2. So that line crosses the point. So this is the best fit line for our prediction. See here. So X, the mean value, X is 3, Y is 4, B1 0.6, like that, right? Now we need to plot it, right? Now we get the interception because 3, 4, right? We can get 3, for example. Now it is 4, right? So there is a point where it starts 2.2. So assume that 2.2, the line crosses like this, right? See here. Now once you draw the line, some of the line points are lies on the line, some of the points are away from that line, right? So we can easy to find out the difference from this is X, right? This way or this way, the difference. Assume that. That is, yeah. Right? So that difference is our error. Is it okay? Now, based on that, we can easy to predict it. So this is actually our example. Now we need to use these things. So here, this is the error calculations, right? Now there is a value of x and value of y. We need to find out the 2.2, right? And that is a regression line, right? Now we need to find out the r squared, right? That's an error. So there is a difference between the actual value and predicted value. So that is our error. Is it okay? Now we'll see how to implement this in our examples, right? In real world things, right? So how to do it? It is very, very simple, right? So this is a Python program for linear regression. So is it clear? Do you have any doubt in this? This is a mathematical and formulation of our linear regression model, right? So any doubt? Shall we continue?
Yes, sir.
Yeah, thank you. So here, so we can implement our regression model in predefined package as well as raw Python statements. So this is the program we need to write for raw statements without any predefined package support. We check and we use scikit-learn. We need to perform the same linear regression. We will see. So we need to make the prediction and relationship between the head brain data set, which is available in the Google. So that is a source. We are using so much data. So here, so this is our data set. I'm collecting from Google, right? So there are the features, right? Now, so there's a gender and age range and head size and brain weight. So we need to make a relationship between these features, right? So this is our data set. So first to import the data set, right? So here, so these are all the packages we need to use for supporting or exploring data you are studying in the previous sessions, EDA, right? So data exploration and representation is done by NumPy and Pandas, right? Now, so we need to import the NumPy and Pandas because we use the raw data from the head brain without any predefined package support. This is especially for representation and visualize our data, right? So Matplotlib especially for visualization, Pandas is data representation, right? And NumPy is also array, NumPy array, right? So how to read the data? So our data is in CSV format. We can read the data in any format, right? So XSL or TXT, or you can directly download it from our web source. You can directly use the URL and extract the data. Make the data is more useful for our model with high performance, right? So head brain. Now, so PD is a Pandas read CSV because I am using CSV file for my purpose or analysis purpose. So I can store this location. So location of your data set is the data set name. It is in CSV format. Now, so we need to see the dimension of data, right? And so it reads the topmost 5 fields or 5 rows in the CSV file because this file contains different fields with different records, right? Now we need X and Y variable because we need to make a relationship between the X and Y, right? Independent and dependent, right? How to do it? Where X is an independent variable, we can keep our head size is a independent variable and y is a dependent variable, brain weight. Right? Now we need to perform or calculate this formula, right? Yes, we need to find out each and everything. We don't know what is x, what is y, and what is b naught and b1. So based on that, we can calculate it. After that, fit our model. Right? So first, we need to find out the mean of x and mean of y. Right? Where it is? Yeah. Mean of x and mean of y. 3 and 4. So in NumPy, we have a method called mean. So NumPy array dot mean x, which gives the mean value, and y gives the mean of y. Now we get 3 and 4. Now we need to find out the formula, right? Numerator and denominator. X minus x bar, y minus y bar. Right? Definitely we need for loop because we need to start with the first value and second value, third value, fourth and fifth value. So it goes in number of iteration based on the length of the data. Right? So we need to get the length of the x. Now we start with the first value, right? So x minus x bar. So x of 5, because it's an array, right? X of 5 is 1 minus 3 into this value, right? 3 of 5 minus mean value 4. Now denominator, ultimately x minus x mean whole square, right? Now we need to find out the m, numerator and denominator for each and every points, right? So finally we can get one addition result. Now we need to find out the c. How to find out the c? Here we have a b naught, right? How to find the b naught? So mean of y minus m into x, because y is equal to mx plus c, right? So we don't know c. Definitely the formula is little bit changed or rewritten like this. C is equal to mean y minus m into mean x, right? So now we can find out the m, c or intercept or everything. Now we need to plot it, right? How to plot? So this is our plotting. Now we have data, we need to plot it. So in red color, right? Or red or orange color. So the plotting x and y, the color is this color. You can change the color because it's RGB value, and the label is regression line, right? This is a regression line. Likewise, we need to plot our data points in scattered because we have plenty of graphs. The scatter plot is best choice for linear regression. So using scatter x comma y, and the color is a little bit different. That is, I think, green color, and the label is scatter plot. Now we need to set the x and y label, right? So x label is head size. It is a independent variable. Now y is a dependent variable, brain weight in grams. Now we set our labels of x and y. Now we need legends, right? So most of the researchers or students has to publish the papers in various conference or journals. They expect the legends, right? So how to specify legends? We simply use plot.legends. It automatically takes the different values and keep in different legends, right? Now, so that plot, we set the x label and y label on legends, and also we show the plot. Now the graph is shown like this. Now we need to find out the predictor value, right? How to find out the predictor value? With the help of the first value, right? Because we know c, we know m value, and we start with the x, first value, and we need to find out the prediction because y is equal to mx plus c. First value, we need to know the prediction, and so this is a sum of squared of residuals, errors, right? SST and SSR, right? So here, oh, it is not there. Okay, so that is an error. Now, so we need to find out the difference between these errors, right? Now we have R2. So the difference between these things. So now the graph shows the points are very closest to regression line, that is highly predicted. The points are away from that line, that's outliers. That's not belongs to that particular prediction result, that is outliers. So most of the research is also consider outliers. Best example, spam, right? In our email box, right? So we cannot remove all the spam mails. Sometimes we get some relevant mail in spam, right? So spam is the best example for outliers. So there are various techniques already implemented, spam filtering, to find out or perform outliers for better model, right? So this is actually our Python program to plot our regressions and predict our results, right? Now, so there are packages which is used to support our machine learning, right? So scikit-learn, which gives all the supports, right? So here we are going to use linear regression, right? Now we are using the mean squared error for identifying the errors, right? Now it is very simple. Only 3 steps is enough to perform linear regression, right? So without understanding these code and logics, we don't know what are the things is performed at the backend, right? So how to create a model? So we have some steps. We create a model and fit the training data and predict the data and plot the line and calculate the errors. Every algorithms needs these steps. So how to create a model? There is a predefined model, right? So linear regression. Now there is a function. We need to fit the x and y because we already have x and y data. So those data are fit in our model because regression is our model. Fit x and y. Now the model is ready. We need to predict x, right? X value. Now the y prediction gets all the predicted value, right? Now the same way we need to plot it. The same code, right? So plotting line x and y and scatter line and set the x label and y label and legends, right? And this is a r squared score of x and y. It gives the error of the particular prediction, right? So mean squared error. So all the errors and its mean is r squared, right? So this is r squared value, right? So this is the model. You can use this way. So this is important while deriving a mathematical model, or you publish your paper, or you understand your model better, right? It is a mathematical way we need to derive our methods. So this is, once you are familiar with that, we need only that particular output. We can make use of these packages and do it in your work, right? So this is a linear regression, right? So now, is it clear? Any doubt? Is it clear? So we move on to next. Yeah, thank you. Next we have some kind of regressions, logistic regression. So far we discussed about linear regression, right? So that is the linear format. So we need to make a relationship between independent and dependent variables, right? So that is regressions. All the data is continuous, dependent variables continuous, right? Now, so we need to perform the regressions model through some categorical values, right? What is categorical value? Suppose we have different categories. We need to categorize the human based on the gender. We have two categories, men and women, male or female, right? Sometimes some groups has yes or no or true or false. So we need to categorize based on some constraints, right? So logistic regression especially for categorical values, right? It never way or it never fits the linear line, right? Because we have only two values, either two categories, either 0 or 1, right? Some of the values in 1 or some of the values in 0. Definitely that curve goes like this, right? It never goes the linear manner because we have categorical data. So this is the formula to find out the categorical data, right? So example here, we need to predict the politician whether he can elect or not. We can win the election or not, right? What is our outcome? The income or the independent variables, it can be different variables or different features. His experience or his symbol or the amount he spent while coming, like that. But ultimately the response is either win or lost or lose. A 0 or 1. That's why we get either 0 or 1. That is a categorical value. If we are having categorical value, you can choose logistic regression to predict it, right? See here. So logistic regression also performs the same way. See here. So this is our package, logistic regression. Previously we used linear regression. Assume that we have a bank new data, right? So the data, so what is the purpose of this analysis means the bank decides whether the customer is eligible for getting loan or not, right? So how do you analyze? Suppose as analyst, you need to analyze or predict the customers and its behavior and their behavior. How to do it? So you have to analyze every features, customers data, right? So here I'll show the bank new. So here, these are all the features, age factor, job and material status, educations, and housing loan is there or loan is and contact details, and we have plenty of features. Ultimately we have only one outcome, right? 0 or 1. So why is the outcome, right? Whether he can eligible or not. If he are eligible, he is eligible, is 1, otherwise is 0. So we can keep OS this, and X we can select the hyperparameter which feature is best for our prediction. We cannot consider all the features for prediction. We need to check which one is the best variable to predict the customer, right? Almost the time is running out, right? I will give some demo, right? So bank new. So these are all the features. Now see here. So we always need numerical data, but we cannot expect the numerical data from all the sources. We can get all the mix up of data, right? From that, we choose our best data. That's a variable to predict it. Right? So this is actually a package, pandas package, to read our CSV file, and we need to drop if there is any null value, because null is leads a performance problem. We need to drop the null values, drop NA. It removes all the null values which is present in this file, and the shape is these records and 21 features. Head returns actually a top 5 records. Right? Now we need to perform various analysis. Right? So you'll study in the further sessions, pandas, numpys, and visualizations. Right? So here I'll give one simple example. Right? So these are all the pre-processing of your data. Right? So here, so we have plenty of features. Now we need to select the best predictor and worst predictor, because predictor variable is independent variable, right? So if it is a strong predictor, then only we can get the strong prediction. So here, if the marital status, it is not a strong predictor, because a single also get a loan. We cannot decide these parameter to decide the eligibility of the customer. So this is not a strong predictor. Now this is a good predictor. Why? Education leads your loan eligibility, right? Because if you earn more money, definitely can get higher degree or higher educations. So those are getting loan very easily when compared to others. So education decides your loan eligibility. So this is a good predictor, right? Likewise, we need to select or analyze the data. Month also a good predictor, and outcome, right? Your salary is also a good predictor, right? Now, so based on the good predictor or bad predictor, we select the features. That feature is keep as an independent variable and perform the certain operations. That is a regression or prediction operations, right? Now, so suppose you have data in non-numerical data, for example, job, right? So if you want to perform some analysis, as of these data set concerned, we don't know job is suitable for prediction. We can select that job, or sometimes we leave the job. For example, ultimately loan needs job, right? So we need to convert these job into numerical values by using dummies. So get dummy is a method. See here, get dummy data of job, right? It collects all the categories and converts to the specific numerical value, right? The prefix, all the feature is prefixed with job underscore. Likewise, all the non-numerical data is converted to numerical for our purpose, because we are using different data set for our analysis, right? So this is for material status, this is for education. So this is a defaulter list according to this example. Data set, housing, housing is house is yes or no. Likewise, loan is availed or not, existing loan. So likewise, we need to get all the values as numerical. Now we need to get, previously we have 21 data set, right? Now we can get 53 columns, because we need to convert everything as a numerical. Now see here, job, material, everything is there, right? Now we need to select the x and y value for prediction. So here we select the x value, independent value, loan number is no. It is not no, right? So that columns are considered as a independent variable. Equal one is equal to yes. That columns are in y. Now we have train and test split to split the data as a training and the testing. Test size is 0.3 because we need to split 70-30 percentage. So the single data is converted to divided into training and testing purpose. Training data set and testing data set. So we can keep 80-20, 80% training, 20% testing. Here 0.3 is a 70%. 70% of data set used for training purpose, 30% for testing purpose. Now we can create a model and fit the model and predict the results, right? So predictions is based on some metrics, precision, recall, F score. So before that, we want to know true positive, true negative, false positive, false negative. What is true positive? The prediction is correct. The actual value also correct. Suppose our prediction is no and actual value is also no. So that is true positive, true negative. So what is false positive? The actual class is no, but predicted class is yes. Right? It is a false positive. False negative, the actual class is yes, but predicted class is no. That is false negative. So based on that, we can evaluate the model. We see the classification report, right? Precision, true positive divided by true positive plus false positive. So this is a correct prediction. And recall is a sensitivity related to our outcome, right? Suppose if you are using false negative, it affects the sensitivity, right? So recall and F score, weight average of precision recall. And classification report we can get. So if you want to know the classification report of the model, you can use classification report, Y test and Y prediction. It shows all the prediction classification report, right? So this is actually a image. If you are using, if you have to include your Jupyter, right? So you can use this package, image package, and you can get it. So this is actually a classification report. Based on that, we can find out our precision, recall, and accuracy, right? So this is a confusion matrix, right? See here, true positive, true negative. This is considered for our accuracy. How to get the accuracy? Accuracy score is the Y test and predictions, right? So this is the logistic regression, right? So that's all of my presentation. So thank you. Any doubt? Any queries?
Participants, if you have any doubts or any questions, you can ask.
Okay, thank you.
Sir, on behalf of our management, our principal and our HODs, I would like to extend my heartfelt thanks for accepting our invitation and delivering the lecture. The session was highly informative and I am sure the participants would have been highly benefited. Thank you once again, sir. Thank you for accepting our invitation and delivering the lecture. Thank you, sir.
Thank you. Thank you.
Participants, I have posted the feedback link in chat. Kindly fill the feedback link. And the next session will start at 10:45. So we'll be having a 15 minutes break. After that, we'll be continuing with session 2 on the safety. Thank you.